So, hello everyone, hope you are doing good and welcome back to my channel. Today is day 7th of the April Daily Leetcode Challenge, and from the last one day, and including today, from last 2 days, we are having graph problems with us. Okay, so today we have a middle level question in front of us, and it's question 1020, number of enclaves. Okay, so let me quickly give you a brief of the what the question is. So basically, the image which you are seeing here in example one, it's basically the satellite picture of a region. Okay, the region can have lands which are represented by one. Okay, so one represents these lands, right? And similarly, it can have water regions, right, which are represented by zero. So what we have see, we can move diagonally. See what it means is we can move along four directions. Okay, here the diagonal movement is abandoned. That means the diagonal movement is not to be considered. Okay, here we are supposed to move only along the four directions. What are the four directions? Top, bottom, right, and left. Okay, we cannot move diagonally. So here move means movement along four directions. Please make this point clear. This particular statement states that we can move from one side to another along four directions only. Here the diagonal movement. Okay, diagonal movement means, for example, I am this one cell which is in the skin color. I cannot move from that to the one which is written in pink color, right? It's a diagonal movement. Okay, such movements are not to be taken in this particular question. Okay, so what the ask of the question is, we have to return the number of land regions. That means the number of regions marked with one, which are not connected to any land in the border region. Please note this question down. It's not a easy question to understand, but a very simple question to code if you once get the hint out of it. Okay, we have to return the number of land regions. Okay, land region means the regions which are marked with one. We have to return the number of such regions which are not connected to any land region along the border. Okay, so this is my statement. If you see the official statement, it's written like return the number of land cells in the grid for which we cannot walk off the boundary of the grid in any number of moves. Okay, this kind of question you will understand only if you take the example. Okay, so first I will start with example two. Why? Let me. Oh, you will understand it on your own, right? Why I'm taking example two first. So see, this is the grid given to us. The number, see, the regions marked with zero represents water because see they are in blue color also, right? So for our help they're given the blue color, and the region marked one will represent land. Okay, they are in skin color. So just try to guess the answer here. Here the answer is zero. You can clearly see here the answer is zero. Why is that so? See, there is no one which is not connected to a one in the boundary. See, these two ones represents. I hope my mouse pointer is visible to you. See, these two ones represents the land along the boundary. Land means region marked with one. So these two ones represent land along the boundary. So we have to give a count of number of ones which are not connected to the lands along the boundary. In this case, all the ones present in this are connected to at least one land along the boundary. So the answer is zero. Now coming to the first example, okay. Now try to tell me how what is the answer. Here the answer is going to be three because see, this is like a land along the border, okay, along the boundary. So we have to give account of number of ones which are not connected to any land along the boundary. So in this case, the ones marked with pink color, the ones I am showing now with my mouse pointer, these are the ones which are going to contribute to my answer. So the answer is going to be three. So these three are the ones which are going to contribute to my answer. The one marked in the skin color is not going to contribute to my answer because it is along the boundary. But one question now I will ask is, see, the skin colored one and the pink colored one, they are connected diagonally, right? So that's why I told you the second statement here. It clearly mentions that the see, connections along diagonal are not considered, only along the four directions. Okay, all connections along the four directions are only to be considered. Okay, what are the four directions? Top, bottom, right, and left. So in this, if you see, the right of this one is a water cell. Okay, the bottom of this one is a water cell. The top of this one is a water cell, and the left of this one is not in the region of consideration. Right. That's why. But see, diagonally, you are not supposed to consider that. Okay, diagonally, you are not supposed to consider that. If something is considered like connected diagonally, you are not supposed to consider that. So this was the question. I hope you are clear with the question. I will again just quickly repeat it. We are given a grid. Okay, its dimension is m into n. The maximum dimension that m can take is 500 into 500. So maximum dimension the grid can take is 500 into 500. It's filled. It's a binary grid. That means only zeros and ones are present in that grid. Okay, and we have to return. So please note it down if you have a pen and paper with you. We have to return the number of land nodes. the number of land nodes which are not connected to any land which is in the border region. Okay, the number of land nodes which are not connected to any land region along the border. Okay, that is the question. Here, what kind of connections we are supposed to use? We are supposed to use only the connection along the four directions. So I hope you are clear with the question, because I've spent a lot of time explaining you the question. Now coming to solution part. So my advice to you will be, I think I should have said this in the starting of the video itself. Please consider the question which is in yesterday's question. Okay, I think it was day 6 of the April Daily Code Challenge. Please consider that question. Exactly same solution you have to take, and you have to just make 2-3 lines of modifications, and you will get this answer. Okay. So my advice to you will be, if you are a regular follower, please once again remind the yesterday's Daily Code Challenge video. Okay, it's exactly the same approach. So see, we are given a land region. I will consider this as a graph. Why should I consider this as a graph? See, my experience tells me that I can do a BFS on this very easily. What is BFS? BFS means once we are at node one. See, once we are at one of the nodes, I can traverse all its adjacent nodes. Adjacent means along top, right, bottom, and like top, bottom, right, and left. Okay, along these four directions, all the nodes I can traverse. Okay, whichever nodes is at a distance one to it. Okay, that is called BFS traversal. So first, my what is my thinking? I am into you have to explain these things, right? I am going to consider the given region as a graph. Okay, and I am planning to do a BFS traversal on it. So whenever I am going to BFS traversal, what are the things required to me? Okay, before coming to that, let us see how we are like making the data structures which will be needed to us. So n is the number of rows. See, I am saying in a bit faster way, but please pause and visualize yourself these things. Okay, n is the number of rows, m is the number of columns, count is for the going to be the final answer which I am going to return. Okay, and is going to be the final answer which I am going to return. Sorry, the count. Okay, and visited thread is a it's a 2D matrix which is of the same dimension as that of grid. Okay, whichever grid see dimension you're seeing in the grid. For example, in this it is a 4x4 grid. Okay, so visitor will also have the exact same dimension. The only difference is grid is a binary matrix, but visited will be a Boolean matrix. It will have only false and true values. False means we have not visited that particular node. Okay, true means we have visited that particular land node. Okay, true will come only in case of land nodes. It won't come in case of water nodes, because we'll be exploring, we will doing the BFS only on land nodes. Please note these points and explain these points in interview if you are asked such a question. And these are going to be the four directions along which for each node I will be searching for a land node. Okay, whenever I get a land node, I will visit its node which are in this direction. So let me explain you this. The first one is a 0, 1. Okay, the first one is a 0, 1. 0 means no movement along the horizontal directions, and top vertical movement, that is going above in the vertical direction. No movement along the horizontal directions, going below in the vertical directions. Okay, no movement in the vertical directions, going right along the horizontal direction. No movement along the vertical direction and going left along the horizontal direction, that is going towards left. Next, what we are doing is, see, I am running two for loops, so you must be knowing that the time complexity will be O of m into n. Okay, I'm using two for loops here. I'm visiting the see two for loops. Why I'm using it? Because I want to visit each element in this node. Okay, the grid given to us has two dimensions. That's why I need two for loops to visit each of the node individually. Okay, so what we are doing next is, if it is a land node and if it is an unvisited one. Okay, what this statement means, if it should be a land node and should be unvisited one. If this is the case, I will start a BFS on it. See, this is a function call. Okay, this is the BFS function. I will do a function call on it. The function will return something. So what it's going to return, I will tell you when why I'm explaining the BFS function, right? It will return two parameters, parameter one and parameter two. If the parameter two is true, I will do something. Okay, what are these things? I will come to that once we are clear with the BFS function, right? So what I'm doing is, if it is a land node, secret equal to one means a land node, and visited of it is false means it is not visited one. Okay, initially all visited will be false only. You can clearly see here, right? If it is an unvisited land node, then we are doing a BFS traversal on it. Okay, so what is a BFS traversal? Let us see. If you are following my videos, then definitely you will be knowing what is BFS traversal and how I'm going to implement it. Always and always, I have taken a cue. See, there are many ways of doing a BFS traversal. You can use the inbuilt data structures also. In Python, you can use DQ structure, but I always prefer using the raw data structures, because for the beginners, for beginners, it's very easy to follow this type of like data structure, right? It will tell them how its internally works. You take a deco and remember some functions that you may not be able to explain it, how it's working internally. Okay, it for finding time complexity it will be difficult for you, right? I am taking a queue. Okay. See, here I'm passing bfs of I comma j. What is I comma j? It is the node for which is a land node at the same time which is unvisited node. Okay. So I'm passing I comma j. I comma j is a coordinate. Okay. Here it becomes x comma y. That I comma j became x comma y here. Okay. I I'm declaring a queue which is empty in the movement. I'm appending. That means I'm inserting x comma y as a tuple. Tuple means, see, this bracket you are seeing, right? This bracket which you are seeing is called a tuple in Python. Okay. This is called a tuple in Python in brackets. Okay, it will be inserted as it is. Okay, this bracket will be there, then two values will be there, and the bracket close. Okay, this will be inserted into the queue. Okay, then node at boundary. This is the assumption which I am going to make. Okay, finally, if see in this point, if I am finding it's not true, I will be changing it as well. So initially, this assumption I am making as false. Okay, node at boundary. That means the current set of nodes which I am visiting, I am assuming that they are not at the boundary. This is assumption. Okay, this is assumption. Okay, now we should see these things, as I said in the last video also. In this question, whenever I'm inserting something, I am marking it as visited equal to true. Okay. When see here I've inserted it, here I'm marking it visited equal to true. Okay. And this is going to be the nodes count, which is in this particular website traversal, how many nodes we have seen. Okay. So this is going to be returned. Okay. This particular which you are seeing here, nodes count, and this particular thing, node at boundary, these two things will be returned from this function, as you can see here. What are these things? We'll come back to that, but let me explain you the BFS process. So while queue is not empty, this thing will continue. Okay, I am popping the leftmost value, which is at the leftmost value means the whatever is index 0, I'm popping that out. Okay, and it will be called double x and double y. Okay, it will be now be called double x and double y. I'm doing a nodes count plus one. Okay, nodes count is equal to nodes count plus one. Okay, because first node came. Initially it was initialized with zero. Now I am doing a plus one. Okay, now for I comma j in direction, that means these are going to be see, I is going to be 0, j is going to be 1, like that it is going to be there for all the four cases. Okay, these are the four cases, right? So idea is for this double x and double y, I'm going to consider its top node, its bottom node, its right node, its left node, right? So that will be represented using triple x and triple y. So I am added I comma j in double x and double y. Okay, so it becomes triple x and triple y. Now I will check whether the double x and double y was a node along the boundary or not. How I will check? If the triple x exceeds n, or if the triple x is less than 0. Similarly, if the triple y exceeds m, or if the triple y is less than 0. When this will happen? When the double x and double y is a root node, that means it's a boundary node. Then the triple x will be a node outside the region given to us. Okay, double triple x and triple y will be a node outside the region given to us. In that case, mark node at boundary equals to 2. Okay, mark node at boundary equals to 2. See, such a node I cannot explore further, because it's not a route, it's not a node along my given region. Okay, it's outside my given region, so I will not explore. But remember one thing, I'm not stopping here. Okay, I'm not stopping here, I'm continuing the search further, because you have to explore all the possible nodes. See, this node might be outside the given region, but maybe other nodes along the right of it, along the left of it, maybe in my given region, right? That's why I will not break the loop here. Okay, if this is a thing, do not do anything. Just stop there. Okay. Such a node we can't explore further. If it is not the case, okay, if it is not a node outside the given region, but it is a land region, if the node which we have see this was triple x scene, double x double y is my node. Okay. I am finding its neighboring nodes. Okay. Triple x double y is one of its neighboring nodes. I am just seeing if it is outside the given region. If it is not the case, I am checking this. If my this particular neighboring node, which is triple x triple y, if it is a line node and if it is unvisited one, if this is the case, then I will append it to queue. And as I've told you already, whenever I append something to queue, I will mark it as visited equal to true. Okay, this particular while loop will continue till all the neighboring nodes of the node x comma y are visited. Okay, all the nodes are explored. Okay, finally I will be returning these things. What is the nodes count? For example, see, if you are trying for this particular one, okay, this one in my image, I am just pointing in my mouse pointer, so it will explore all the three ones here. Okay, all the three ones will be explored. So nodes count will come as 3, and because these nodes are not along the boundary, so the node at boundary will be in its initial value, which is false. Okay. So finally, I'm returning nodes at boundary is equal to false. If it is not at boundary, then it will return true. Okay. If node at boundary is already false, false equal to false, which will return true. So when the second parameter, what it will return? It will return if the node is at boundary or not. Okay. If it is not at boundary, it will return true. If it is at boundary, it will return false. Okay. So please know this, otherwise it will be very difficult for you to understand, right? If it is not at boundary, it will return true. Okay. And this is the nodes count of the while doing the behavior traversals, which all node we visited. This is the count of that. Okay. Now coming back to the function call. So as I told you, it will return two parameters. The second parameter is true when it is not at boundary. Okay, the second parameter is true when it is not at boundary. The first parameter returns the count of the behavior traversal in the while doing the behavior traversal, which are not visited. So if my second parameter is true, I am going to add the first parameter to my global count. Okay, as I told you, this is COUN double T. Okay, please note these points. It is COUN TT. Okay, this COUN TT, which is double T, will be added to my initial count, which is COUN single T. Okay, it's COUN single T. Okay, it will be added to this. You can maybe rename it in a better way, but I have just done it like that. Okay, in an interview, you should be making meaningful names out of it. Okay, you should not be doing it like that. And finally the count is being written. So what the idea is, if the it's a land node and it is not connected to any land node along the border, then we are going to count it. Okay, if it is a land node which is connected to a land node along the border, we'll count again, but see, this node will anyway will return the count, but this particular condition will be not true. Okay, a node at boundary will be true here. True is equal to false, which is false. Okay, it will return false. When it is false, we will not add it to our global count. Okay. Now coming to space and time complexity of this problem. See, we are using a visited array which is of the same dimension as the grid array. So time complexity of m into n, right? Time complexity of m into n. And coming to the it was the space complexity. Coming to the time complexity, you can clearly see there are two follow-ups involved here. We are visiting each of the elements of the grid array, right? At the same time, one more thing you have to notice. See, for each of the nodes, we are visiting four directions. That means time needed to explore one node is equal to time needed to explore four nodes. Okay, so it will be of the order 4 into m into n, but we are considering the upper limit of it. Okay, so O of m into n, right? So that's again the time complexity O of m into n. So yeah, friends, that was all for today. So my request to you will be, please see yesterday's problem also. It was very similar to it, and believe me, just 3 to 4 lines you have to change the code, and you will get the answer for this question. Okay. So my advice will be, please see that question also. Please see that answer as well. Okay. So yeah, friends, that was all for today. If you like my video, please subscribe and see. My aim is to solve my code, and if I feel I'm confident with my code, I'm sharing it with you as well, right? So that is my aim. If you like this journey, if you like solving with me, then please subscribe. That was all I have to say, and thanks a lot.